No, 120 volts outlets are not always on a 20 amps breaker. The amperage of the breaker that a 120 volts outlet is connected to depends on the amperage rating of the outlet itself. 120 volts outlets can be rated for either 15 amps or 20 amps, and it is crucial that they are connected to a breaker that is rated for the same amperage as the outlet. Connecting a 120 volts outlet to a breaker that is rated for a higher amperage than the outlet can be extremely dangerous. This situation could allow too much current to flow through the outlet, potentially causing a fire. It is unsafe to put a 120 volts outlet on a 30 amps breaker. In electrical systems, overcurrent protection devices, such as circuit breakers, are designed to protect circuits and equipment from overloads and short circuits. When the current in a circuit exceeds the rated amperage of the circuit breaker, the breaker trips, interrupting the flow of electricity and preventing damage. The size of the circuit breaker is determined by the ampacity of the conductors in the circuit and the type of load being served. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. Conductors are typically sized according to the National Electrical Code, or NEC, which provides tables and guidelines for determining the appropriate conductor size for various applications. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type, size, and installation conditions. When selecting a circuit breaker for a 120 volts outlet, it is important to consider the ampacity of the conductor supplying the outlet and the load that the outlet is expected to serve. For a standard 15 amps outlet, a 15 amp circuit breaker is typically used. For a 20 amps outlet, a 20 amp circuit breaker is required. Using a circuit breaker with a higher amperage rating than the outlet or the conductors is a violation of the NEC and can create a fire hazard. If a 15 amps outlet is connected to a 30 amp circuit breaker, the circuit breaker will not trip if the outlet is overloaded. This could cause the outlet and the conductors to overheat, potentially leading to a fire. In addition to protecting against overloads and short circuits, circuit breakers also provide protection against ground faults. A ground fault occurs when a live wire comes into contact with a grounded surface, such as a metal enclosure or a water pipe. This can create a dangerous electrical shock hazard. Ground fault circuit interrupters, known as GFCIs, are special types of circuit breakers that are designed to protect against ground faults. GFCIs work by monitoring the current flowing through the hot and neutral conductors in a circuit. If there is a difference in current between the two conductors, it indicates that current is leaking to ground. When this occurs, the GFCI trips, interrupting the flow of electricity and preventing an electrical shock. GFCIs are required in many areas of the home, such as bathrooms, kitchens, and outdoor locations, where there is a high risk of electrical shock. When installing a 120 volts outlet, it is important to follow all applicable electrical codes and safety guidelines. This includes using the correct size circuit breaker, properly grounding the outlet, and using appropriate wiring methods. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation. Always ensure that the power is turned off at the circuit breaker before working on any electrical wiring. Use a voltage tester to verify that the circuit is energized before proceeding. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Inspect the wiring and components for any signs of damage or wear. Replace any damaged or worn components before proceeding. Ensure that all connections are tight and secure. Loose connections can create resistance, which can cause overheating and potentially lead to a fire. Use wire connectors that are appropriate for the size and type of wire being used. Do not over-tighten wire connectors, as this can damage the wires. When installing a new outlet, make sure that it is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Connect the ground wire to the grounding terminal on the outlet. Use a level to ensure that the outlet is installed straight and plumb. This will help to prevent the outlet from being damaged or pulled out of the wall. After the installation is complete, test the outlet to make sure that it is working properly. Use a receptacle tester to check the wiring and grounding. If the outlet does not work properly, or if there are any wiring errors, consult a qualified electrician. The NEC specifies the requirements for electrical installations, including the types of wiring methods that are permitted, the size of conductors that are required, and the location of outlets and other electrical equipment. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Local electrical codes may also apply, so it is important to check with your local building department to determine the specific requirements in your area. In addition to the NEC and local electrical codes, there are also a number of industry standards that provide guidance on electrical safety. These standards are developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. Following these standards can help to ensure that electrical installations are safe and reliable. When working with electricity, it is important to be aware of the potential hazards and to take the necessary precautions to protect yourself from injury. Electricity can be dangerous, but if you follow the safety guidelines and use common sense, you can work with it safely. Firstly, always turn off the power at the circuit breaker before working on any electrical wiring. Secondly, use a voltage tester to verify that the circuit is de-energized before proceeding. Thirdly, wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Fourthly, inspect the wiring and components for any signs of damage or wear. Fifthly, replace any damaged or worn components before proceeding. Sixthly, ensure that all connections are tight and secure. Seventhly, use wire connectors that are appropriate for the size and type of wire being used. Eighthly, do not over-tighten wire connectors, as this can damage the wires. Ninthly, when installing a new outlet, make sure that it is properly grounded. Tenthly, use a level to ensure that the outlet is installed straight in plumb. After the installation is complete, test the outlet to make sure that it is working properly. If the outlet does not work properly, or if there are any wiring errors, consult a qualified electrician. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the installation. A qualified electrician has the training and experience to perform electrical work safely and in accordance with applicable codes and standards. They can also help you to troubleshoot electrical problems and to ensure that your electrical system is operating safely and efficiently. When choosing an electrician, it is important to select one who is licensed and insured. A licensed electrician has met the requirements of the state or local licensing board and is authorized to perform electrical work in your area. An insured electrician has liability insurance, which protects you from financial loss if they damage your property or cause an injury while performing electrical work. Before hiring an electrician, ask for references from previous customers. Contact the references and ask about their experience with the electrician. Also, get a written estimate from the electrician before work begins. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. Review the estimate carefully and make sure that you understand all of the terms and conditions. Do not hesitate to ask the electrician questions about the estimate or the work to be performed. Once you have chosen an electrician, make sure that you have a written contract that outlines the scope of work, the payment terms, and the schedule for completion. The contract should also include a warranty clause that protects you from defects in workmanship or materials. Keep a copy of the contract for your records. Throughout the project, communicate with the electrician regularly to ensure that the work is progressing according to your expectations. If you have any concerns or questions, address them promptly with the electrician. By following these tips, you can help to ensure that your electrical project is completed safely, efficiently, and to your satisfaction. Remember that electricity is a powerful force and should be treated with respect. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. Putting a 120 volts outlet on a 30 amps breaker is a dangerous and potentially life-threatening situation. The reason for this is that the outlet itself is only designed to handle a maximum of 15 amps or 20 amps of current. If you were to plug in an appliance that draws more than that amount of current, the outlet could overheat and cause a fire. Additionally, the wiring in the wall that is connected to the outlet is also only designed to handle a certain amount of current. If you were to overload the circuit, the wiring could also overheat and cause a fire. The circuit breaker is designed to protect the wiring and the outlet from being overloaded. If the circuit breaker is rated for 30 amps, it will not trip until the current exceeds that amount. This means that the wiring and the outlet could be subjected to a much higher current than they are designed to handle before the circuit breaker trips. This could lead to a fire or other serious damage. It is always important to use the correct size circuit breaker for the wiring and the outlets that are connected to it. If you are not sure what size circuit breaker to use, consult with a qualified electrician. The electrical code, specifically the National Electrical Code, or NEC, provides detailed guidelines on how to properly size circuit breakers for different types of circuits. Following the NEC is crucial for ensuring electrical safety. Section 210.21 of the NEC addresses the permissible loads for branch circuits. This section specifies that a 15 amps receptacle can be used on a 15 amps or 20 amps branch circuit, but a 20 amps receptacle can only be used on a 20 amps branch circuit. Further, 210.21b3 dictates that the rating of any one cord and plug connected equipment cannot exceed 80% of the branch circuit ampere rating. This means on a 15 amps circuit, the maximum load for one appliance should not exceed 12 amps, and on a 20 amps circuit, it should not exceed 16 amps. These regulations are in place to prevent overloading the circuit, which could lead to overheating and potential fire hazards. When it comes to conductor sizing, NEC Table 310.15b16 plays a crucial role. This table provides the ampacity of insulated conductors rated up to 2000 volts, based on the conductor's size and insulation type. For example, copper conductors with THHN insulation, which is commonly used in residential wiring, have different ampacity ratings depending on their size. A 14 American wire gauge, or AUG, copper conductor with THHN insulation is typically rated for 15 amps, while a 12 AWG copper conductor with THHN insulation is rated for 20 amps. It is important to choose the correct size conductor for the circuit to ensure that it can safely carry the expected load. The size of the circuit breaker should match the ampacity of the smallest conductor in the circuit. In other words, the overcurrent protection device should be rated to protect the weakest link in the circuit. This ensures that the circuit breaker will trip before the conductor is overloaded, preventing overheating and potential fire hazards. Ground fault circuit interrupters, GFCIs, are essential safety devices that protect people from electrical shock. GFCIs work by monitoring the current flowing through the hot and neutral conductors in a circuit. If there is a difference in current between the two conductors, it indicates that current is leaking to ground. This could happen if someone touches a live wire or if there is a fault in an appliance. When the GFCI detects a ground fault, it trips quickly, interrupting the flow of electricity and preventing an electrical shock. NEC Section 210.8 specifies where GFCI protection is required in dwelling units. This includes bathrooms, kitchens, garages, outdoor locations, and other areas where there is a high risk of electrical shock. GFCIs are typically installed in these areas to provide an extra layer of protection for people. Arc fault circuit interrupters, SCIs, are another important safety device that protects against electrical fires. SCIs work by detecting arc faults, which are dangerous electrical conditions that can occur when there is a break or a weakening in the insulation of a wire. Arc faults can generate high temperatures and can ignite nearby flammable materials, leading to a fire. SCIs are designed to trip quickly when they detect an arc fault, interrupting the flow of electricity and preventing a fire. NEC Section 210.12 specifies where SCI protection is required in dwelling units. This includes all branch circuits that supply outlets or devices installed in dwelling unit bedrooms, family rooms, dining rooms, living rooms, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, or similar rooms or areas. SCIs are typically installed in these areas to provide an extra layer of protection against electrical fires. In summary, When dealing with 120 volts outlets and circuit breakers, always ensure that the breaker amperage matches the outlet's rating, typically 15 amps or 20 amps. Never use a higher amperage breaker than the outlet's rating, as this poses a significant fire hazard. Following the NEC guidelines for conductor sizing, overcurrent protection, GFCI protection, and OFSI protection is crucial for ensuring electrical safety in residential and commercial buildings.